Hello student. So today our topic is geometrical meaning of the zero of polynomial. So in our syllabus we have to deal with linear polynomial, quadratic polynomial, cubic polynomial and little bit introductory part of biquadratic polynomial. So starting with geometrical presentation of linear polynomial. As you know, the general formula of the linear polynomial is ax plus b. Now, our first priority to plot a graph by taking an example of one linear polynomial. Let us see. So here one linear polynomial is taken, that is p of x is equal to 2x plus 3, and we take two distinct value. One is x is equal to minus 2. Plugging that value into the equation, polynomial, you get minus 1. And x is equal to 2, if you plug in again, then you will get 7. Now once you plot the graph of this, here you can see, you can find out the two distinct points. Here there is a 2, 7. One is 2, 7, and another that is 0, 3. And you find that you will get the straight line, and due to that it is given the name linear polynomial. Now here one characteristic feature of the linear polynomial is its intersect x-axis. That graph that is in the form of line which intersect x-axis at only one point, and that is minus 3 by 2, 0. So what are the characteristics of the graphical presentation of linear polynomial? See, graph of the linear polynomial is straight line, as we see before. It's a straight line. Graph intersecting x-axis only in one point. So given polynomial has only one zero. So here only consider where the graph intersect to the x-axis. So when you construct a line by joining this point, that line only intersect at the one point to the x-axis. So it interprets that it has only one zero. As given polynomial has only one variable x, so if line intersect y-axis to any point, do not consider it. You can see here it is also intersect to y-axis also, but that we haven't have to consider because polynomial is in a term of x. So only consider the value in which the graph intersect to the x-axis, and it intersects at x-axis at one point, so it has 1 0. Understood? Here you can see another line which is parallel to x-axis. What is its interpretation? Above graph is a linear graph but do not intersect to x-axis, so it has no zero. Prior condition that we had discussed. And it is a graph of zero polynomial, means that is having any constant value 2, 3, 4 or minus 5, anything. There are no term which consist variable in this type of form. So under that condition, if you draw the graph, that is linear but obvious parallel to x-axis, does not intersect to x-axis. Get it? So such kind of polynomial is called zero polynomial. So that is a graph of zero polynomial. Now we talk about geometrical representation of quadratic polynomial. So first we talk about the general form of the quadratic polynomial, that is ax square plus bx plus c. One example is given, x square minus 3x minus 4. So here we take one by one the different values of x, minus 2, minus 1, 0, 1, 2, 3, 4 and 5. And plugging that values, we get different values of p of x. If you plug in minus 2, you will get 6. If you plug in minus 1, you will get 0. If you plug in 0, you will get minus 4. If you plug in 1, you will get minus 6. If you plug in 2, you will get minus 6. And if you plug in 3, you will get minus 4. If you plug in 4, you will get 0. And if you plug in 5, you will get 6. Understood? So while we constructing all those points, you can see here. One can see here. That is one point. That is minus 2,6. That is another point, minus 1, which is intersecting to x-axis. So it has 1, 0 here on the x-axis, that is minus 1, 0. You can see another point, that is 1,6 here. Another, that is 2, minus 6. Here that is 3, minus 4. And again, if you see here, you will find another point, that is 4, 0. So by connecting all those points, you will get the curve. And you can say this curve as a parabola. That curve is a characteristic name, that is called parabolic curve. And you can find that curve intersecting x-axis in a two distinct point. Okay? Let us see further. So here you can find out further. There are two parabolic curves, but there is a specificity in a graph 1 and graph 2 also. Here in a graph 1, the parabolic curve is open downward. Here parabolic curve open downward. It's open downward. And in graph 2, the parabolic curve open upward. You can find that. So what are the interpretation of all this? See, we find that it intersecting both the parabola intersecting x-axis in a two distinct points. So first thing we can say that quadratic polynomial has at most two zeros. So graph of polynomial intersect at most two distinct points on x-axis. The graph of quadratic polynomial is curve shape and particular characteristic name, that is parabolic. Graph 1 is open downward. You can see that it's open downward. So that also interprets something, that also express something. If it's open downward, so whatever the quadratic polynomial that you have, for that the coefficient of x square is less than 0, means a is less than 0. Graph 2 is open upward. Here you can find that. And it is open upward, so coefficient of x square is more than 0, greater than 0, means positive, a greater than 0. Here also you can see that x square minus 3x minus 4, the coefficient of x square is 1, that is positive. So it's open upward. You can easily observe that thing. Is it? Okay. Now you can see these two graphs. Can you? Graph 3 and graph 4. What are the interpretation? Can you guess it? Of course, both are curve, both are parabolic. Okay. But here you can observe one thing. In the graph 3, the parabola intersect x-axis at only one point. That is A, and it is open downward. While in a graph 4, the parabola intersecting x-axis only in a one point and open upward. So what are your interpretation? Definitely both are the curve of quadratic polynomial, which has only 1 0 because parabola intersect at one point of x-axis. As graph open downward, for the graph 3, we can say a less than 0, means coefficient of a, that is 0. Graph 4 shows quadratic polynomial which has only 1 0 because parabola is intersect at one point of the x-axis. As the graph open upward, a is greater than 0 for the 4 one. Quite easy. Let us see further. Graph 5 and graph 6. What is the speciality of 5 and 6? Can you guess? Both are in a one of the half plane of the x, either upward or downward. Graph 5 is upward to the x axis and graph 6 is downward to the x axis. Do not at all intersecting to x axis anywhere. So obvious that is a graph of quadratic polynomial, but do not intersecting to the x axis. So we can say that graph 5 and graph 6 do not have any real zeros. They do not have any real zeros. And once again we can say that the coefficient of a in a graph, coefficient of x square in a graph 5, that is positive, and for graph 6 it is negative because it is open downward. Get it? Okay. Now we talk about geometrical representation of cubic polynomial. General form of cubic polynomial is, by mistake here printed quadratic, but correct it to cubic polynomial. Sorry for mistake, just correct it. It is cubic polynomial. So general form of the cubic polynomial is ax cube plus bx square plus cx plus d. One example is given, x cube minus 4x. Now plugging the different values of x, minus 2, minus 1, 0, 1, 2, 1 by 1. If you plug in minus 2, you will get 0. If you plug in minus 1, you will get 3. If you plug in 0, you will get 0. If you plug in 1, you will get minus 3. If you plug in 2, you will get 0. See the graph? What kind of graph it is? Can you say? Here two parabola, two curves which are connected by each other. The two parabola are connected by each other, connected with each other. And you can see that it intersects. We can say it is either in an N shape or inward N shape or S shape. we can find the different shapes of that. But in all the time for the cubic polynomial, you find that the two parabola connected each other. So what are the characteristics? The curve graph where the two parabola are connected intersect x-axis in a three distinct point. You can see minus 2, 0 at 0 and 2, 0 in a three distinct points. So polynomial has 3, 0 and its graph of cubic polynomial. So cubic polynomial has at most how many zeros? 3 zeros. So here intersecting points, number of intersecting points on x decides number of 0. That is also you can find out there are two curves. There are two curves, one that is here and another that is here. You also find here also one curve this side and another here. Can you see to it? Yes. Now see this graph again. Graph 7 which is intersect only at one point, that is O, which is on x-axis. So it has only 1 0. And graph 8 that is intersect at the two distinct point. You can see that. One that is here at the 0 and another at the 1. So it has at most 2 zeros. So graph 7 and graph 8 are the graph of cubic polynomial having two parabolas connected. Graph 7 intersect x-axis in a one point, so it has one real zero. Graph 8 intersect x-axis in a two distinct points, so it has two real zeros. Get it? Now see the last presentation. How many parabola you can find here? Can you say how many number of parabola are connected here? Can I show? That is 1. That is 2 and that is 3. That one 3 2 1. So 3 parabola are interconnected. Geometrical representation of, sorry, by mistake it's written cubic, you have to understand that is biquadratic polynomial. Geometrical representation of biquadratic polynomial. General form of the biquadratic polynomial is ax raised to 4 plus bx cube plus cx square plus dx plus e. And you find that it is intersecting x-axis in a 4 distinct point. Can you find that point? That is 1, that is 2, that is 3, and that is 4. So given graph is a of biquadratic polynomial. Three curves, three parabolas are connected, intersecting x-axis in a four distinct points. So it has at most 4 0. You can find out such three interconnected parabolas which are only intersect in 3 or 2 or 1 or 0 point on the x-axis also. But at most 4 point for of intersection you can find. So that is a graph of biquadratic polynomial. Can you understand this? Don't goes on the upper instruction, that is by mistake misprinted. Only whatever I speak focused on that and the instruction which is given below the graph. I hope you can understand that and haven't have any doubt regarding the graphical representation. Here we declare this lesson to be completed. Assignment, I had already given 4 printed worksheet to you that you have to finish. After that, by Monday, I provide few more sums for the practice, which are previous year board questions. Just go through it. If you have any doubt, ask to me in a WhatsApp. Okay? So, bye. Have a good time.